Hello everyone and welcome. So today we're going to chat about Azure Virtual Desktop AVD and showing how to set up, configure and implement from scratch a fully working AVD solution using FSLogix profiles with Azure Premium Storage, private endpoint with Active Directory integration. This will help you build a virtualized desktop infrastructure VDI solution at enterprise scale. The diagram shows hub and spoke networking set up in Azure, and we have an Active Directory domain controllers in our hub network, synced to Entra ID using Connect Sync for our cloud identity. Then we have AVD in the cloud, where the gateway, web access, and broker are fully managed by Microsoft. The Azure Virtual Desktop service architecture may look familiar to Windows Server remote desktop services. It's similar components but with a difference, as Microsoft manages the infrastructure and brokering components like web access, gateway and broker, where with the traditional remote desktop services you would have had to install and configure these components, and it's much easier, and this is all done at a click of a button now. The only part we manage is our own session host virtual machines, which are Windows 10 multi-session in the spoke network as shown, and it contains all our company apps installed within that VM. Then we can connect using secure port 443 from our end user devices with the remote desktop client installed, and Azure Virtual Desktop works across devices including Windows, Mac, iOS and Android. So as stated, port 443 is used for all connections initiated from clients and session hosts to the Azure Virtual Desktop infrastructure components. In this document, it shows you what you need to open up outbound from the session host to connect to Azure Virtual Desktop, and we must have access to the following FQDNs and endpoints. Allowing these fully qualified domain names and endpoints is essential for a reliable client experience. So in this video, we will first create the storage private endpoint in Azure using AD integration, and then we assign Azure and NTFS permissions on the AVD FSLogix share. We will give some guidance and calculations on storage performance and steady state and sign-in burst IOPS, depending on how many users you have in your AVD environment, and if the users are light, medium, or heavy users, and what our profile sizing will be on average. An AVD gold image will then be created with all our company apps installed and FSLogix installed, and then that image will be captured and stored in the image gallery for future use, so we can version number that image, and then we'll roll that image out in our AVD environment to our session hosts in the spoke network. And then we test all this out and demo AVD using FSLogix profiling and show it all in action. And as always, please like, subscribe and comment, and let's get started. We will follow the MS documentation here so we can check that all the prerequisites are in place. Links are in the description. Okay, good. So first off, we are going to create our Azure storage account for our FSLogix user profiles in the Azure portal. So we go to storage accounts and then we click create. We choose our resource group and we have one already created to contain our storage. If you don't have one, click create to create one. And then at next, the storage account name. This can contain letters and numbers and can be 24 characters. However, in this case, we limit this to 15 characters or less due to the AD authentication, integration and NetBIOS naming limitation. And we choose our region UK South. Now, this is important based upon performance. I would always recommend premium storage, as standard only gives up to 10,000 IOPS per file share and premium is 100,000 IOPS. With premium storage, it's dynamic, so we can change it. And to note, you pay for what the size is, so be aware of this and always check with your bill payer before provisioning. And as you will see later on in the video, choosing the size for premium storage also allows us to choose the calculated steady state IOPS and sign-in burst that's expected from our session host VM, so we will cover that later on. So we choose premium and file shares and locally redundant LRS for this demo. And then we click next and leave the defaults under advanced. And then we click next. Now under networking, we don't want public access. We want to choose a private endpoint that our session host will connect to privately, and it won't be across the internet. And this is best for performance and low latency. So next we create the storage private endpoint. Okay, great. So let's click add private endpoint, and then we choose the resource group, the region, and we give it a name. Storage sub resource file is the only option, so we select that. And then under networking, we choose our spoke network and subnet, where our Windows 10 session host will also be deployed. And we want to create a private DNS zone, so click OK and then next, and then under data protection we will leave the default soft delete for file shares to retain for 7 days in case we need to recover within 7 days. So click OK, click next, and we leave the encryption as default. Click next and then we review and create. Okay, so here is our private endpoint that we created within the last section. Now let's create a DNS zone for this to resolve to the private endpoint. So we go to DNS configuration and then we copy the FQDN and also the private address this will resolve to. On our DNS server we can create a new forward lookup zone and we paste the storage fully qualified domain name without the storage name into the zone name. Then create a new A record with the storage name and paste the IP address we copied earlier. And now we can flush DNS and we can ping the full storage name, and NS lookup shows we can resolve to our private IP address of the storage within Azure. Okay, good. So now we will create a new file share for FSLogix profiles under the storage account we created. So go to File Shares, give it a name. Here with Premium it's dynamic, so we can change the size and you pay for what the size is. So remember, you will get billed for the provisioned capacity. So we can do some rough calculations and determine how many IOPS you will need in the environment. And please remember, these will depend on your environment and what's shown here for guidance. The challenge is that storage provisioning based on Azure Files Premium will continue to be a guessing game because of its provision model. The good thing is we can increase our storage if we see performance issues with login, etc., and this will increase our IOPS that's required. When choosing between standard and premium file shares, I would always recommend premium. It's important to understand the requirements of the expected usage pattern you are planning to run on Azure files. So choosing premium storage will give you a large amount of IOPS, extremely fast data transfer speeds, and very low latency. And with premium, it's dynamic, so we can change the size of the storage to increase performance. So let's take a look then. So we can see the provision capacity is 1024, and then under performance maximum IOPS aka steady state is 4024 currently, and the sign-in burst IOPS is 10,000. So if we take an average, our FSLogix profile container per user in our environment will be somewhere between 5 to 20 gigabytes in size. In our environment we have 1,000 users, so 1,000 times 20 gig is 20,000. So we enter the total profile size provision capacity of 20,000. We will go with the total steady IOPS of 20 per user to be on the safe side, and we want during logon max 50 burst IOPS. So our rough calculations as a guide for 1,000 users are as follows. We enter the total profile size of 20,000, and then we can see our performance IOPS metrics then change and increase. The maximum IOPS is 23,000, so that's higher than our calculated 20,000. The login or sign-in burst is 60,000, so that's higher than our calculated 50,000. If we decided to take the provision capacity down to say 15,000, as our profiles are a little smaller than expected, then this reduces the performance and doesn't come in line with our calculations. So we will stick with 20,000 capacity to meet our requirement, and please remember these are rough calculations and will be different in your environment as they are rough guidelines. Okay, let's click next. Here we can edit our backup policy if needed. And now let's create our share. And once created, we can change, as it's dynamic, so we can change the size and you pay for what the size is. As this is a demo, we don't want to use up all our credits, and we will reduce this now by clicking on change size and performance, and this will reduce to the minimum of 100. Okay, so now we are going to integrate our Azure storage that we have created with Active Directory. So this is so we can connect to it using our synced Entra ID identity. So under File Share Settings, click Identity Based Access, and we can see this is not configured yet, and we want to choose Active Directory Domain Services. So click into this, and as you can see we have documentation to set up Active Directory Domain Services, and then if we click Step 1, Enable Active Directory Authentication, first of all we need to download the AZ Files Hybrid module. Then we extract that file, and then we go back to the document. There's a series of PowerShell commands we need to run. So if we copy that, and then if we open PowerShell where we extracted the files earlier and change to that directory, and then we can paste the PowerShell we copied. So first of all we need our subscription ID, resource group, storage name and SAM account name, and then we paste it into our script we are going to run. So we created the OU for our storage account, and if we right click the OU in Active Directory, Users and Computers, and we go to the Attribute Editor tab, we need to copy the distinguished name and paste this into our script. We also change the domain account type to a computer account within the script. And then we run this by selecting and copying and pasting parts of the script as follows. Run the set execution policy, then the copy to PS path PowerShell, import our module, then we run the connect AZ account command to enable us to log into our Azure tenant using the correct credentials. Then copy all of the parameters we created earlier, run the select the subscription command, and then the join AZ storage account command to register the storage account under the target OU. When we go back to our target OU, we can now see our computer storage account object joined to the Active Directory domain under our OU that we created. Okay, so now we're going to assign Azure and NTFS permissions on the FSLogix share. So we have two groups in Active Directory under the group OU. One is for storage admins and the other is for Azure Windows Virtual Desktop users. In the storage account group we have a user called CI admin, and in the Azure Windows Virtual Desktop group we have our users that will be logging in to our Azure Virtual Desktop. So both groups are synced from on-premise Active Directory to Entra ID. So we go into our storage account and then we go to Access Control, IAM, and then we add a role assignment. The first role we're going to choose is Storage File Data SMB Share Evaluator Contributor, and then we are going to select our storage admin group. Second role we're going to select is the Storage File Data SMB Share Contributor, and then we select our Windows Virtual Desktop group. For the storage admin group, that will contain our admins that will administer the storage account file share. The users group contains our Azure Virtual Desktop users that will be logging into our session hosts. We can connect to our storage by simply copying an Active Directory authentication script from the portal, or we can just simply map a drive. So we're going to just map a drive just by copying the FQDN and changing this. We change this as follows, and then we can just copy and paste this and map a drive the traditional way. If we right click on my computer and go to map network drive, and then we're going to apply the recommended ACLs to the map network drive as follows. So we are logging in as CI admin, which is a member of the storage admin group that we set up earlier. So right click the map network drive, go to properties, click advanced. We don't want to enable inheritance, and then remove the following permission entries. Then we add create owner as a principal with modify and apply to subfolders and files. We click add again, select a principal, and we will select our storage admin group and give full control to the share. Click add, select a principal, and we will add our domain admins now as well to give full control to the share. Click add again, select a principal, and we will add our Windows Azure Virtual Desktop group as well and give modify permissions to the share and select that this applies to this folder only. Click OK, apply, and click OK and OK again. Okay, now we're going to perform the FSLogix GPO template install. We download FSLogix and then we extract the folder, and then we'll follow the README. And we'll copy the FSLogix ADMX and ADML templates to the following folders on our domain controller. So we copy the ADML file into policy definitions and an ENUS directory, and the FSLogix ADMX into the policy definitions directory. These are located in the Windows directory on your domain controllers. Then we can create a new GPO and apply this to our OU where the session hosts will be built. Edit the GPO, then as we copied the FSLogix templates and files, we now see the FSLogix folders and settings under our GPO here. In the next section, we will go through applying the standard config, following the example configurations in this document. Okay, good. So in this section, we will go through applying the standard config, following the example configuration in this document. All links are in the description. So let's enable FSLogix first, and then enable the delete local profile when VHD should apply. When FSLogix determines a user should have a profile container and a local profile exists, FSLogix will permanently delete the local profile. So this setting is recommended to ensure users don't use local profiles and lose data unexpectedly. Let's also set the profile directory name showing the username first by enabling the flip-flop setting. This provides an easy way to browse the container directories. Locked retry interval, which specifies the number of seconds to wait between retries. We set this to 15. And locked retry count. So this specifies the number of retries attempted when a VHDX file is locked. So we're going to set this to 3. So both of these lock settings decreases the retry timing to enable a faster fail scenario. Profile type, we will choose normal. Reattach interval, which specifies the number of seconds to wait between retries when attempting to reattach the VHDX container. If it's disconnected unexpectedly, we will set this to 15. And reattach retry count, so that specifies the number of times a system should attempt to reattach the VHDX file container. If it's disconnected unexpectedly, we set that to 3. Size in megabytes, so that's a maximum size of the user's container in megabytes. So newly created VHDX containers are of this size. Existing containers are extended automatically to this size during user sign-in. You can increase this value at any time, but you can't decrease it. Decreasing this value doesn't cause existing VHDX containers to shrink. So we will set this value as default to 30 gig. Volume type, we want newly created files. They should be of type VHDX. So VHDX is preferred over VHD due to its supported size and reduced corruption scenarios. For the VHD locations, we will copy the storage path that we created and then amend and paste this into this section. Okay, so it's required to register the following resource providers in the Azure portal to allow the creation of your AVD instances in the next section of this video. So let's go and do that now. Under subscriptions, go to resource providers and we will register Microsoft Desktop Virtualization and Microsoft Virtual Machine images. So next up, let's create our Windows AVD gold image and install all our apps into that image. So let's create our gold image. So this will be our image version baseline with all our apps installed on it. So we can roll this out to our session host. So we go to virtual machines, we choose our resource group, we give the VM a name. We don't need redundancy for this demo. We choose region UK South. Image will be Windows 10 Enterprise multi-session. So multi-session allows multiple concurrent interactive sessions. So previously only Windows Server could do this, and the business can benefit from the cost advantages of multi-session and use existing per user Windows licensing instead of RDS client access licenses. Let's now select the image size. So for this demo we will choose a standard D2S v3. So type the username, admin username and password to log into the VM. Confirm that you have all the correct licensing in place and are eligible to use Windows 10 or 11 multi-tenant, and we will leave the disks as default. We select our spoke network and VMs will be placed here. So have a look at the diagram. That's exactly where the VMs will be placed in our spoke. So for this demo, we will use a public IP, but for production, we'd recommend you connect to this gold image using Azure Bastion. We want to delete the public IP when this VM is deleted, and we will leave everything else to default and then review and create. And then next, we will install the FSLogix client and apps to our gold image. Okay, so we are now logging into our AVD gold image for virtual desktops that we installed in the last section. And we will now install Office, and we've already installed Firefox and Notepad++ for the purpose of this demo. Here you would install all your company apps needed for your organization to the gold image so it can be Sysprep, and then it can be used to roll out to session hosts in Azure Virtual Desktop. We will also install FSLogix as well. So once that's done, let's Sysprep the image once all our apps are installed in the next section. Okay, we've installed all our apps to our gold image. We're happy with the image. So now we're going to Sysprep that image. So we go to C:/Windows, System32, the Sysprep directory. We want to generalize the image and then choose Shutdown. Then click OK. Next, let's capture the image. So now our image has been Sysprepped and shut down completely. We can capture the image as a gold image in the Azure image gallery, and then we can put a version number on that image. So let's click into the VM and then we click capture and we select the AVD gallery, or we can create a new one. We make sure generalize is chosen from the operating system state. We then create a new target VM definition and then include the version in the name. And there is also an option to provide additional information here if required. So we choose a version number and we select Premium SSD LOS for this storage SKU. And then we click Next and we create the image. So finally we have our AVD gold image with all our apps on it, and we've sysprepped it and we've captured that image in the image gallery, ready to create an AVD host pool and session hosts from our gold image in the gallery. So from the Azure portal, let's search AVD and go to Azure Virtual Desktop. We go to host pools and then we click create. We choose a resource group to contain the host pool. We give it a name, we choose a location, and we want a desktop host pool type where users will access the full desktop. Available with pooled or personal host pools. And the host pool type we can choose either personal or pooled. So personal is where each session host is assigned dedicated to our individual user. So personal host pools provide dedicated desktops to end users for performance and any data separation requirements. Pooled is where user sessions can be load balanced to any session host in that pool. So there can be multiple different users on single session host at the same time. We have deployed the multi-session desktop image for this reason, to provide a shared remote experience to users, and this will ensure lower costs. Therefore, we will choose pooled here. For the load balancing algorithm, we can choose either breadth first or depth first. Breadth first will evenly distribute new user sessions across the session hosts in a host pool. Depth first adds new user sessions on one session host until the maximum session limit is reached, and then once that session limit is reached, any new user connections are directed to the next session host in the host pool until it reaches its session limit. So for this demo, we will choose breadth first, and we don't have to specify a maximum session limit for the number of sessions. Click Next and we will add our session host virtual machines here. To add the name prefix for the session hosts, to conform to your naming convention, and a number will be appended to the end when VMs are deployed. We will add the version number of the gold image here we deployed, and this will then automatically get appended as AVD host 01-0 1, 2, 3, etc. once built. We choose UK South for this demo and trusted launch. We now select the gold image we created earlier from the shared images within the gallery. And for the purposes of this demo, we will choose a minimal spec of VM here and choose to deploy 2 VMs from this image with premium SSD storage. And we select the VNet of our spoke network. We don't want any public inbound ports to this VM, as this is all controlled by the AVD management plane. We will domain join these session hosts with the correct accounts that have domain admin permissions in the Active Directory. Domain to join is cloudinspired.com, and we copy the distinguished name from the session hosts OU in Active Directory and paste it here for the OU path. Lastly, we confirm the local admin account credentials on the VMs and click Next. And then we want to register a desktop app group and create a new workspace. Click Next and create. So this will take some time and depend on how many hosts you are deploying. After some time, we can see we have the 2 session hosts created. And when we refresh the OU in Active Directory, then they appear all domain joined. We can go to AVD, and in the host pool we can see the session hosts are now available to use, and we can rename the application session desktop to something more meaningful to represent the app group. And then next we will add users to allow access. Okay, so we will now add our group which contains our users to give them access. So we go to assignments, We click Add, and then we select our group. Next, we install the client on a Windows device to access AVD. Download the remote desktop app from the links in the description or from the Microsoft Store and install from here. And once done, we will then subscribe using the client in the next section. We will now test permissions are assigned correctly to the Azure FSLogix share. Once the app is installed, click subscribe and we sign in with our AVD1 user. Once we log in, we can see the Windows 10 desktop that we created and assigned. So now let's log in with AVD1, and when we map a drive to the Azure storage containing the FSLogix share, we can see the profile created for AVD user 01. Now let's log in using AVD user 2, and mapping a drive, we now see two profiles, one for AVD user 1 and one for AVD user 2. When logged in as AVD user 2, we can't open or view AVD user 1's profile, so we get an access denied, which is correct. We can only view our own profile for AVD user 2. So let's now test the profiles between hosts to see if we get the same config and settings that we apply. So we log in with AVD user 01, and then we go to computer management. We can see disk 2 with the profile attached for AVD user 1, which is great. And now we configure some settings for the profile. Let's make Firefox a default browser and change the home page and the site appearance to dark. Let's go to the Microsoft site and we can bookmark this, and we can also create a test folder and file on the desktop. Let's now log out. Under session hosts within the portal, we can see we have two VMs running. Now let's stop any new connections and put the first session host where we were logged into before in drain mode. Then we log in again to the only session host available and see if we get our profile delivered correctly to this new host. Okay, so we're looking good. We can see we have our test folder and file on the desktop. So the profile has pulled down correctly. Also, the dark image for Firefox is applied together with our Microsoft bookmark. As you can see, we were logged into the second AVD host, so our profile is attached here. To make you aware, there are some antivirus file and folder exclusions which you need to apply, otherwise they will conflict with FSLogix and file scanning. We can target conditional access policies to the AVD app, which is very useful to apply to locations or specific client apps. So we can target the AVD app, and then we can apply various conditions around this app just using normal conditional access policies. I can see we have a standard policy for MFA, and we can require the device to be marked as compliant and also apply session controls like sign-in frequency, etc. Earlier on in the video, we domain joined an Azure storage account to Active Directory domain services by using PowerShell. Now we don't want this computer account to attempt to change its computer account password after 30 days, so we can set the maximum machine account password age here to 0 via group policy. Okay, so thanks for watching the video. As always, please like, comment and subscribe to the channel if you haven't already so you don't miss any future content. Catch you next time. Bye for now.